Howdy, AP PreCal, it's Ms. Kosh. I am continuing the FRQs from this year. So I have worked them already, but it's been several days, so I've forgotten. Okay, so let's jump on into this one. This number 3, this is the same as we expected. So they keep giving us this little curve with F, G, J, K, and P. So we should be pretty comfortable with this. So let's just make sure we get all the details right. So it says the tire has a radius of 9 inches and a person rolls the tire forward at a constant rate on ground level as shown in the figure. Point W on the edge of the tire, retouches the ground at time t equals 1/2. Okay, so right here we're going to have, this is going to be, what are they giving us? They're telling us it's h of t. Okay, so h of 1/2 is going to touch the ground. That's going to be 0. And then it also tells us the next time it touches the ground at t equals, this is also going to be h of 5/2. Okay, so the tire completes a full rotation the next time it touches the ground. Okay, the maximum height is 18 inches, which makes sense. If the radius is 9, here it's going to be at 9, and here it's going to be at 18. Okay, so when does it get there? Well, I would do h of 0 is equal to 9, then h of 1/2 is equal to 0. H of, and if I have him rolling the wrong way, it works out the same. Because if this is 0 or this is 1, like, anyway, is that true? Well, okay. It's gonna start in the middle at time 0, and then it goes down lower first. So it's going to start in the middle at time 0, and then it's going to go down first. So I would either put this to be 0, or when does it get back here? It gets back there at h of 2. Okay, so here's h of 0, here's h of 1/2, here's h of 1. This up here would be h of 3/2, and how big is that? That's 18. Well, okay, so this was 0, 1/2, 1, 1.5, or 3/2. This is 2. This would be 2.5 or 5/2. And then this is also going to happen at h of 3. And this would also happen at h of, well, not 5, 6, so 7/2. Okay. So now you just have to figure out which one of those you want to put on the curve and where you want them to go. The midline is at 9. So I might go ahead and say that this is time, I don't see any reason why we can't say 0, 9. And then this becomes 1/2, 0. This becomes 1, 9. And this is 3/2, 18. Okay, so what does that make this point? Well, negative 1/2, 18. Now, if it bothers you to have a negative, and I don't know, one of my colleagues didn't want to see negatives there, then what we're doing was we could also say that here, this h of 0 is also what happens at h of 2. So you could call this 2, 9. Can you read that? Hopefully you can see that orange. I know it's not a great color. And then this becomes, well, so then what would this be? This would be 5/2, 0, and this would be 3, 9, and this would be 7/2, 18, right? 2, 2.5, 3, 3.5, and then so then what does this become? This would be 1.5, 18. So me personally, in my classroom, if you worked this problem in green, I would expect a particular set of equations. If you labeled things in orange, hopefully you can see that. It's not the best color for showing up, but then I would expect a different set of equations. Okay, I don't see any reason why I can't use one or the other. But I didn't write this problem. I don't get to be a grader. So, okay, let's do it in green first. So what I would do on my answer key is one of the options would be, oh, how long does it take it to do everything it's going to do? 2 seconds. So 2 pi over b equals 2, so that means b equals pi. What's my amplitude? 9. So one way to do it is negative 9, and then this is sine, and they did tell me sine, of pi times, well, just t, I could just say t, and then plus, I shifted up, my midline is at 9. So this allows me to go down first. I could also say it's positive 9 sine, and then start here. So then t minus 1 would shift me here. Actually plus or minus, because this would now be a minus 1, or this would be a minus 1 in green. So you could tell me plus or minus. And those correspond with your green, my brain stopped, with the green coordinates. If I'm using the yellow or orange or whatever this color is, then you could say h of t is equal to, this would be a 1 right here. So one of your options would be 9 sine, you're still going to have that same pi with b, then this becomes t minus 1 plus 9. That would correspond to this right here. Cool. And there's more. I mean, there's infinitely many more. So if you think it's something else, put my equation and your equation in Desmos and see that they match. Alrighty. Okay, so now they're saying what happens with k to p. So where's k? K to p is this little piece. The graph is increasing and positive. Positive and increasing. Okay, and then what's happening with the average rate of change on that interval? Well, it's concave down, so the average rate of change is decreasing. I'm too lazy to write out that word. There you go. Let me use a better pen. Okay, here we go. So on this one, they want us to, this is no calculator. I like 4. I think 4 may be my favorite. Yeah, FRQ 4. So we want to solve for this equation. So g of, let's see, I need more space. E to the x plus 3 is equal to 10. Okay, right? Because they wanted us to solve for that in the domain. So I can take the natural log of both sides. Why? Because the natural log of e is gone. This is x plus 3 is equal to the natural log of 10. Subtract 3. Natural log of 10 minus 3. Just make sure that it's obvious that the natural log, this, maybe put parentheses if it makes you feel better. Or write it this way, negative 3 plus the natural log of 10. It does not become, the short answer is it does not become the natural log of 7. That would be wrong. Okay, the next one, we're saying arc sine of x over 2 is equal to pi over 4. So what do I need to do? I need to undo arc sine by taking sine of both sides. When I do, I get x over 2 is equal to sine of pi over 4. We are really, really good at our unit circles, so we know that this is root 2 over 2. We need to multiply both sides by 2, and x is equal to root 2. I would argue those are pretty straightforward. I would argue I do more difficult things in class. Okay, so this one, they want us to squish together the logs. Okay, j of x would be equal to, I don't know why they insist upon putting base 10. To me, that's unsophisticated. I'm like, why would you be sloppy like that? Why are you making life harder? So I'm not going to do it. I don't know what they actually think. So this is log of 8. 8 times x to the 5th is going to get multiplied by 2x squared. So when we add, we're multiplying. I'm taking longer than I need to. Okay, this becomes log of 8 times 2 is 16. You add your exponents, so 16. X to the 7 minus, this becomes log of x to the 9th because this goes up here. And now we need to squish these together with division. 16 log, it's not a log. 16 times x to the 7th over x to the 9th. I would be happy with log of 16 over x squared. Did that fit the requirements? Your results should be in the form of log base 10 of expression. Okay, put a base 10 to make them happy. That to me is silly. It's understood. I don't know why we're doing that. Okay, need more scratch paper. Okay, this next one, I think I did this wrong on my answer key earlier. One of my students said, oh, whatever. And I was like, oh. Okay, this k of x is equal to, so 1 minus sine squared is going to be equal to cosine squared. This one we've nicknamed in my class. We call it the Big Daddy. Over sine of x. What is secant? Secant is 1 over cosine. Now we're going to lose a cosine on the top with that one. So cosine x over sine of x. Hopefully you recognize that this is cotangent of x, which is equal to 1 over tangent of x. And I think the directions said, write it in a single term involving tangent. So it's 1 over tangent. Somehow I wrote, oh, it's just tangent. Well, it's not. It's 1 over tangent. Okay. And this one was my favorite, and the kids did not like it. But basically they're saying, take this equation and figure out what values in the domain give us an output of 0. Okay, so I'm going to undo everything and try and solve this equation. Okay, so cosine to the -1, so to undo our cosine, I have to take the cosine of both sides. And so then I get tangent of 2x is equal to cosine of 0. Hopefully you know from your unit circle that cosine of 0 is equal to 1. Okay, now I have to do the inverse tangent. Now on this, though, it doesn't, this graph right here, there are infinitely many answers. There are infinitely many things I can plug in here that have a tangent value of 1. So, so we're going to write this as, 2x is equal to, well, when does tangent equal 1? Tangent slope, it equals 1 at pi over 4 plus pi k. And now I need to get rid of that 2. I can multiply everybody by 1/2, and I get x is equal to pi over 8 plus pi over 2k. I like to then include where k is an element of the integers. We nickname that Kez. Okay, I think that's right. If you caught anything in any of these videos that you think I did wrong, comment below, and we'll go from there. All right, like, subscribe, comment, all the things. Have a good one.